Yes. First question, concentration of reactant changes from the 1 mole to 0.75 mole in 25 minutes in a liter vessel. So, what is the rate of the reaction? Here, rate of the reaction, rate is equal to dx divided by dt. So, what is the change in the concentration? So, from 1 to 0.75, but reaction is not given here, divided by time interval 25 minutes. So, rate of the reaction 0.25 divided by 25 is equal to 0.01 or 1 into 10 to the power minus 2. Okay. So, what's unit of this one? Mole per liter per minute. Okay, mole per liter, this unit is mole per liter per minute. Okay, so answer is 1 into 10 to the power minus 2 or 10 to the power minus 2 is a correct. Option third one is a correct. Okay, next I go for second question. The first order reaction was started with the decimolar solution of the reactant. 8 minutes 20 seconds later, its concentration was found to be m by 100. So, rate constant of the reaction. We know that. What is the formula for the rate constant? Rate constant of the first order reaction, K is equal to 2.303 divided by T log of R naught divided by R. Or we can also written this formula. K is equal to 203 divided by T log of A divided by A minus X. Here A represents the initial concentration. This is also correct here. I take that previous problems, it's okay. So, here the first order reaction was started with decimolar. Decimolar means 0.1. 8 minutes 20 seconds later, its concentration was found to be m by 100. M by 100 means 1 by 100. So, initial concentration is means R naught is equal to here they given as 0.1 decimolar, and R, concentration of R after 8 minutes 20 seconds is m by 100. M by 100 means 0.01 molar. Okay. So, time is, so what's the time taken for this one? 8 minutes 20 seconds, because 8 minutes 20 seconds, because problem is a answer is given in terms of a second. That's why it is expressed in terms of a second only. 8 minutes, 8 into 6, 480 plus 20, 500 seconds. Okay. Now I substitute all the data in the above equations. So, K is equal to 2.303. Time taken for this one is a 500 equal to log. So, what is initial concentration? 0.1. What's the remaining concentration? 0.01 molar. Okay. So, here 2.303 divided by 500 log of, it become 0.1. Okay, it can written as 1 into 10 to the power minus 1. This one it becomes 1 into 10 to the power minus 2. Okay, this power will becomes here. Means answer is a 10. Log 10 answer is a 1. So, then you simplify. This one can write as 2303 into 10 to the power minus 3 divided by 500. This is a log 10. Log 10 answer 1. So, if we simplify here 4, because 500 ones are 500 fours are, okay, means 2000, some 300 something get it here, 4.6 something get it here, into 10 to the power minus 3 second per second, second inverse is the final answer. Option fourth one is the correct here. Okay, D, fourth one correct options. Next question, for the reaction 2A plus B gives a C plus D. The rate of the reaction with respect to A is 0.06, with respect to B is how much? Here, for the reaction 2A plus B gives a C plus D. So rate of the reaction with respect to A given, we want to find out B with respect to A. So minus 1 by 2 change in a concentration. Change in the concentration of A divided by dt. Okay, minus 1 by minus change the concentration of B divided by dt, but equal to 0 because concentration C and D did not mention anything about the values. That's why it is taken as a 0. So with respect to A given, so minus 1 by 2 with respect to A 0.006. Okay, with respect to B find out, so dB by dt is equal to 0. So that's why dB by dt is equal to it become minus, or it become minus here. So 0.003 is the final answer here. But here actually there is a small mistake in the option. In second option 0.003, not 0.03. So that's why second option is a correct here. Next question. Okay. The half-life period of the first order reaction is 20 minutes. The time required in minutes for the 60% of the reaction to be completed. Here, half-life period of the reaction is a first order reaction 20 minutes. So, half-life period is given here. So, T half is equal to 0.693 divided by K. We know this one. Okay. So, half-life period of the first order reaction given means T half is given, or K is equal to 0.693 divided by K equal to T half. What's the T half here? 20 minutes. Okay. So second method, time required in minutes for 60% of the reaction to be completed. 60% of the reaction completed. So I can do here K is equal to 2.303 divided by T for 60%. This is for the 60%. Log of initial concentration, so 100 divided by 60 minus 100 minus 60, 40. So this has become 2.303 T for 60%, log of 2.5, because goes here to 2.5, get it. Now this equation you consider as a second equations. Okay. So first equation I can be modified. This actually, you know that how to get this equation, 2.303 into log 2 equal to 20. This answer, this 0.693 you can express it as 2.303 log 2 divided by 20, because log 2 answer, log 2. Okay, here log 2, because we already solved this here in the derivation part, because you know that K is equal to 2.303 divided by T log of A by A minus X. A by A minus X. So 2.303 divided by T log half of this one, means half of this one become log here A by 2, means we get log 2, get it finally while solving this problem. Log 2 get it, log 2 answer 0.3010, 0.3010 multiplied by 2.303, final answer 0.693. I continue that part here. Instead of 0.693 divided by 20, I can express it as 2.303 log 2 divided by 20. Now this expression taken as a 3. taken as a 3. Now you have to compare equation 2 and 3. Comparing these two equations, equation 2 and 3, you have to compare it. From equation 2 and 3, final conclusion is from equation 2 and 3. I write here equation 2. So equation 2 is now from equation 2 and 3. 2 and 3. Equation 2, 2.303 divided by T for 60% log 2.5 is equal to 2.303 into log 2 divided by 20. Okay, so this one here 2.30 will be get cancelled here. It will be cancelled. Next, while solving here, solving the data, while solving the problems. So I want to, for the T for 60%, T for 60%, I want to need it. If final conclusions is log 2.5 divided by T for 60% is equal to log 2 divided by 20, get it here. Okay, so now I want to, for the T for 60%, T for 60% is equal to 20 into log 2.5 divided by log 2. This is the final answer. So options, second one is correct because 20 into log 2.5 divided by log 2. So time taken for the 60% is equal to second option is a correct here. Okay, I continue for next problems, the third problems. Okay, next problems. Rate the constant of the reaction 2N2 nitrogen pentoxide 2N2O5 gives 4NO2 plus O2. Okay, there is small change, not N2O2, 4NO2 decomposition is 3 into 10 to the power 5 second inverse. If the rate of the reaction given, what are the concentration? Because it is the example for the first order reaction. That's why rate of the reaction, rate is equal to K into concentration of a N2O5 power is 1. Because it's the example of the first order reaction. So here rate of the reaction is given. If the rate is 2.4 into 10 to the power minus 5. Okay. Then rate constant is given. Rate constant of the reaction is 3 into 10 to the power minus 5. What are the concentration of the nitrogen pentoxide? So now concentration of nitrogen pentoxide N2O5 is equal to 2.4 into 10 to the power minus 5 divided by 3 into 10 to the power minus 5. So it will be cancelled. So answer is 0.8. Okay, but here approximate answer given 0.6 is approximate answer. That's why fourth one is the correct options here. Okay, next problems. Okay, the rate of the first order reaction A gives a product is 7.5 into 10 to the power minus 4. When concentration of A is 0.5, what are the rate constant of the reactions? Here, this is a first order reaction. That's why K is equal to 2.303 divided by T log of initial concentration divided by remaining concentration. So 2.303 divided by T time. So first order reaction, the rate constant he asked, no? So here rate of the first order reaction given. What's the concentration? 0. What's the rate constant? Okay, here rate of the first order reaction given. So you can do this way directly, because this here question is A gives a product, is the first order reaction. That's why rate is equal to K into concentration of A. Whatever the rate of the reaction is 7.5 into 10 to the power minus 4. So rate constant K find out. What's the concentrations here? 0.5. So K is equal to 7.5 into 10 to the power minus 4 divided by 0.5. Okay, answer is 1.5 into 10 to the power minus 3 is a correct options here. Okay, options third one is the correct here. Okay, next one, the first order reaction, the concentration of the reactant decreases from 0.8 to 0.4 in 15 minutes. The time taken, the concentration changes from 0.1 to 0.025 is. Here a first order concentration reactant changes from 0.48 to 0.4. So first order reaction means K is equal to 2.303 divided by T log of R naught divided by R. I take two different cases. The first case is K is equal to 2.303. What's the time taken for this one? 50 minutes. Log of initial concentration 0.8 divided by 0.4. Okay. Second problems, time taken for the concentration changes. So second problem, so K is equal to 2.303. Time is a find out here. Time find out. So log of whatever initial concentration 0.1 divided by 0.025. Okay, second problem. So if we solve this one here, so 2.303 divided by 15, so log, okay, this answer is 2, get it here, but we know log 2 answer. Okay, if you go for this one, okay, this one here 2.303 divided by T log, okay, log. So if you solve this way, 0.1 divided by 0.025, you have to solve this one. Here 0.1, so you can write as 1 into 10 to the power minus 1. This one you can write as 1, 2, 3. So 25 into 10 to the power minus 3. So we'll solve 0.1 divided by 0.025. So, but we know 1 by 25 means 0. Okay, 1, 0, 4. Okay, 10 to the power here minus 3 goes up, minus 3 goes up, so minus 3 goes up here. So that's why here you get 10 to the power minus 2, get it here, means plus 2, get it, because 10 to the power minus 1 into 10 to the power plus 3. So minus 1 plus 3 minus 1, so equal to minus here plus 2. So we can written as 4 into 10 to the power minus 2, means 10 to the power minus 2, 10 to the power plus 2 will be cancelled. So final answer it get it 4 here. This answer is log 4. Okay, this log 4 now I can written as a 2.303 T log 4, you can write as 2 into log 2, correct, no? Because log 4 you can write as 2 to the power 2. So 2 to the power 2 means a to the power m formula, so you get 2 into log 2, get it. Then you compare these two equations. This is taken as equation 1, this is taken as equation 2, comparison. These two equation comparison, make the comparison of these two equation. So that's why equation 1 and equation 2 comparison. So from equation 1 and 2 we have, so equation 1 2.303 divided by 15 log 2 is equal to 2.303 divided by t 2 into log 2. Okay, it will be cancelled. Here 2.303, 2.3 cancel, log 2 cancel. Okay, so final answer you get here 1 by 15 is equal to 2 by t. So t is equal to 30. Final answer. Okay, t is equal to 30. 30 minutes is taken. The time taken for this one 30 minutes. Okay. Yes. Now next problem. A first order reaction next one. A reaction is the first order with respect to A as the rate constant 6 minutes. If we start with the concentration A is 0.5 mole per liter, when would be the concentration value 0.05 mole per liter? So rate constant is given here. So K is equal to 2.303 divided by T log. Okay, initial what if the reaction start with 0.5? When would be the concentration? When it be the concentration 0.05? So remaining concentration A minus X is equal to 0.05. So time find out, but rate constant given. So K is given. So T is equal to 2.303 divided by T 6. Now, so log this one you can written as a 5 into 10 to the power minus 1. This one you can written as a 5 into 10 to the power minus 2. 1 2. Okay. So here this will be cancelled. 10 to the power minus 2 goes up, 10 to the power plus 2. So it become log 10. Log 10 answer 1. So finally T is equal to 2303 into 10 to the power minus 3 divided by 6. So it will be the 6 ones are 6 threes are. So 0, this is around 3 18. Okay, 3 8 something 4 into 10 to the power minus 3. So we can written as this one 0.384. Okay, this is the final. So options, fourth one is the correct. The fourth one is the correct. When time is equal to 0.384 minutes, concentration of the concentration A becomes 0.05. So that's the fourth one is the correct. Next one. Okay. The half-life of the reaction is 12 minutes, starting with 100 gram of nitrogen pentoxide. How many grams of nitrogen pentoxide will be remains after period of 1 hour 30 minutes? Here start half-life nitrogen peroxide N2O5 dissociated as 2NO2 plus half O2. Half-life period is given, T half is equal to 12 minutes. 12 minutes. So starting with 100 gram, they take 100 gram, 100 to 50. Time taken is 12 minutes. Continuation. 50 to 25. Time taken is 24. After 1 hour 36 minutes. This is the questions here. So next. Half of this one 36 12.5. Okay, next 48. Okay, 6.25. 48. Okay, next 60 1 hour. Okay, 1 hour 3.125. Next 72. Okay, 72. It equal to, it get divided by 2. So 1.1.115 11 here 625. Again 84. They can ask Okay, again you get 0.7 divided by 2 here. Okay, 0.7, then here 1 is remaining, so 8125. Again half of this one means 96. Okay, 96, 0 point after this one you get 0.3. Okay, 36 something you get it. Okay, this is actually time 96 minutes. 96 minutes is equal to 1 hour 36 minutes. It's correct, 36 minutes, because here 1 hour. After 1 hour we get this much, 3.125. Again 36, 12, 24, 36. Okay, so how much remains? 0.36 is the remaining. Approximate answer 0.32 is the correct. After 1 hour 36 minutes or 96 minutes, what is the amount of nitrogen pentoxide remaining? 0.32. This is the final answer. Okay, thank you.